All right. So, my name is Joseph. I am an information janitor at Simply Measured in Seattle. That means that when things go awry, it is my job to grab the mop and bucket and clean up after it, often at 2 in the morning. So, that's who I am. Who are you guys? Who's a developer? Okay, that's almost everyone. Who didn't raise their hand? What do you guys do?
QA.
QA?
IT, web ops.
Web ops. Okay. My people. So I am more traditionally called a system administrator, or they seem to be calling people DevOps now. I'm not going to cringe at that in front of you, but that's more or less what I do. So to get you in the frame of mind that I'm coming from, I want to ask you to go through a mental exercise. Have you guys ever set up a home server, or a production server would be cool too, and had the hard drive fail, or an update go wrong, dependency conflicts when you install something go crazy, or maybe this didn't happen on your server, but maybe your parents' computer got mysteriously slow, and you wanted to figure out why. Why is it doing this? Well, that's what I do for my development team at Simply Measured every day, and try and build tools to help them answer these questions for themselves. So very often what I do is I help them take something they've written, often in Go or Ruby or Java, and get it into production. Or take something that's in production and then change it and make it better. Or take something that's in production and isn't acting right and tweak it a little bit so that way it works better. And I'm sure, so there's one other question I want to ask. So of all the developers in here, who writes code that they want to be in production someday? Okay. Also, who likes getting paid for doing good work? Okay. Those are important, because if you didn't raise your hand, feel free to go to the back, get a soda, go to the bathroom. It's really confusing getting to the bathroom, by the way. There's a key, and then you can't get back in. It's fun. But with the stuff I'm going to show you, you guys will be able to depend less on guys like me. And I'm sorry, I didn't catch your name. Vince. Who. So that way we only have to get up at 3 in the morning to solve problems, and you never do. So the first step, obviously, is taking this Go code that maybe you wrote over the weekend for fun and getting it into production, because that's always a good idea. So to do that, you've got to automate your build, you've got to make a thing, right? And then you probably are depending on other stuff, so you got to make sure that you get all those other things together the right way, and then you've got to get your thing onto the production servers. Okay? Get the stuff, make it into a thing, get it on the servers. Pretty straightforward, right? So the easiest way that you can do build automation is basically what comes with the Go tool. Everyone's played with Go enough to know this, right? Go get goes and gets all your dependencies. Go build compiles your code, and then Go test makes sure that it doesn't explode and cause civilian casualties.
Why is this D?
D? So D only downloads it. So if you're building, say you want to install a Go package that has binary scripts, if you don't do the -D, it will build them and stick them in a bin directory in your Go path. So that's very useful if you just want to install some tool that's written in Go. It's really easy to install it with GoGet. But if you're just wanting to build this on, say, a build machine like Jenkins or Travis, you don't need to do that. You only need to build it once, and so you can do a -D to only download things.
Are you dealing with how do you get specific versions?
Next slide. This guy's worked with Go, apparently. Okay, so this is great, right? This is ideal, and if at all possible, download the page on the Golang site that talks about packages and read it a dozen times until you can almost always do this with every project that you do. You'll save yourself a lot of headaches. But if you can't do that, most projects use makefiles. I've seen some that use CMake, and that's, I mean, your life decision. But either do this or use a single script build system, and you will make people happy, your coworkers and your build server, and things will be better. So that's if you own all your own code. But presumably you guys are smart enough to know that you don't want to write everything from scratch all the time. So you depend on other people's work and stand on their shoulders to get a little bit further. And GoGet is very excellent for that. It allows you to talk to GitHub, to code.google.com, to Launchpad. I used one project from Launchpad. It's still around. But the problem with that is you can't lock it to a particular version. And if you're not maintaining that other code base, they could introduce bugs or breaking changes in their API. I'm sure you've never had code that you've depended on actually do that to you and have it bite you right as you're trying to deploy a project to meet a release date. But someday it'll happen, and you'll hate it. So KR, whose name I can never, Keith something, is from Heroku. He writes a lot of good C and Go code. And he's built a tool called GoDap. And it just uses a JSON file, more or less like what you see up here, to lock your dependencies to a particular version. And this makes it work just like Bundler or Maven or any other dependency manager that lets you lock things specifically. It does do transitive dependency resolution, but it will only get you so far. If most of the time you're going to want to manually tease out your dependencies to lock them down as well, because transitive dependencies only search through the code and figure out what they depend on and don't actually lock anything unless you tell it to. So this will save you a lot of pain if you work with open source libraries. So once you've grabbed all your dependencies, built a Go path with your dependencies, and then either run make or go build, you should just have a single binary, or maybe a binary and a couple of support files. And ops folks are absolutely in love with this. It's amazing how many ops projects have popped up in the last year and a half, because all you have to do is drop the single binary. There are no other dependencies once you've built it, assuming you built it for the right platform. So that's great. You just stick it in a tarball, unroll it onto a machine, and you're good to go. Your weekend project is now in production, potentially. But presumably you didn't get all the features you wanted to do out this weekend, or maybe it's a little slow, or maybe you need to change a few things. Well, the next thing you've got to do is actually put some changes into production. And maybe you're used to doing Capistrano's style deploys and Rails and using YAML files, but things are slightly different in the Go world. The main things that you're going to want to do are configure services, then configure sets of services, cross-coordinating services, and then also manage the rollout of that change, because you probably don't want all your changes happening at the same time. So the first thing you're used to doing is local configuration. Everyone's acquainted with flat files, right? Big flat JSON file, it has all the values you could want to put in it. That's totally normal and very common. And the JSON package is obviously great for that. If you're interested in the Google way of doing things, Google is very fond of using command line flags. I have even heard it rumored that they got to a point where their usage of command line flags got so prevalent that they needed to patch the kernel to allow them to have more command line flags to pass to the thing, because the process length was not sufficient in stock kernels.
So is there a reason they're doing that, or is it just doing this?
I mean, it's not worse than the others. For some values of worse.
If you wanted to, like, say,
I'm listening to Pasha kernel.
Instead of running program, you want to know how it's configured. Like, you can send it to a file, you can get that.
Later slide. You're psychic. You've been reading my... He's psychic, okay? So you're not allowed to bet on this talk, okay? Okay, so then the next thing is getenv. If any of you have deployed into Heroku or read 12-factor app, or gone through the Go Academy Advent calendar, you've probably thought about this approach to things. It's very common. It's nice because you get to inspect things from, say, your proc file system. It's very easy to interact with these and have dependent child processes keep the same configuration, that sort of thing. But sometimes these keys and values, they're not quite as much as you want. And for situations where you really need a bazooka, so that way you can have a Turing-complete configuration language to change things at runtime, because it's obviously a good idea for you to be doing this to your production systems, well, then that's what Lua is for. And if you've played with Hekad, or you've looked at the Luar package, you can do this, and actually we at Simply Measured are currently working on preferably not runtime configuration changes from Lua, but having a domain-specific language for our work that's implemented in Lua, so we can simplify some of the more commonly changing code.
I've seen someone that created an interpreter for Go, so if you wanted to create a Go-based configuration.
That's pretty awesome. Okay. I would love to see a link to that. Okay, so once you've got your... Oh, I'm sorry.
Just specifically about JSON files, if you're going to put all of your configurations in JSON, separate the files. Like, if you're going to do it, like, don't have one giant, huge configuration, then we can't comment it out. We can't put comments in there.
It's true. The other thing is config directories. If at all possible, please try and support config directories, because it's very common for you to have a system, like general application configuration designed by the developer, and then a, say, environment-specific configuration, and even a system-specific configuration. And it's nice to not have to stick those things all in the same file. So if you can support config directories when you're doing flat files, it's
What
the
do you mean
blessing.
by config directory? Conf.d?
So basically, you include all of the files in a directory and then merge them together.
Okay.
Yeah. So you've got to define precedence rules. Typically, you sort alphabetically when you do that. But if you're going to support flat files, please support a directory. Things like hosts, Etsy hosts, are really very frustrating for system administrators when they do have to work in systems, when they tune those things, because they don't support config directories out of the box, whereas things like syslog or cron all do, and they're much easier to work with and use configuration management tools because of that. Okay, so assuming you've got your local configuration, you'll also are probably running systems on multiple machines. Presumably you've got a master and a slave of a database, or you've got multiple machines behind a load balancer, and you need to coordinate how the features that you're rolling out or configuration changes that you're rolling out become visible to the production users of the service. So the two canonical examples of this kind of coordination are blue-green deployments, or gradually migrating from one set of a code base to a future set of a code base. This can be done by using a zookeeper or etcd lock and throttling the number of machines that are down at a particular time, that are in group A in a particular time, in group B at a particular time. A friend of mine is currently using that to make sure that no more than a certain number of machines are having Chef apply a configuration and thus potentially go down at a particular time. Additionally, if you're dealing with things that need to auto-discover, for example, Elasticsearch, Memcache clusters, heck, even Zookeeper, Surf is excellent for group membership discovery and event propagation. So if you can allow your services to respond to the addition or removal of an individual node, Surf, it's not a highly consistent data store, but it is excellent at pushing these kinds of events around a group to do fast configuration changes as opposed to a configuration management language like Puppet or Chef. So once you have your local changes configured and you've managed to coordinate the changes that have to happen in between services, you're going to want on each machine to be able to do things like gracefully reload that configuration, or perhaps gracefully restart the process and start a new version of the binary in order to upgrade the code in place. So in order to do that, you're going to want to use Unix signals. Unless you're on Windows, then I would love to talk to you because I have no idea how to use Go on Windows. But it's actually very simple to do signal handlers in Go. This code is not very complex. You'll notice that I take the os.interrupt and os.kill signals, and I attach a notifier which hooks onto that channel there and calls this function whenever you receive a SIGINT or SIGKILL signal. So all I've got to do is start this program, and then it loops, sleeping for 10 seconds at a time. And if I press Control-C or hit it with actually a kill -9 does not actually get trapped by this. I learned that later. You will see it print out received interrupt, and it will exit. Anytime you need to do things like reload resources or perhaps stop listening to a worker queue and fork a new child process, which we will talk about more in a second, this is a very lightweight way of dealing with it, and it doesn't get in your way. In other languages, you often need to create queues to safely handle signals. This handles it for you. So what we've discussed so far is local configuration and configuration directories, intercoordination between services, and gracefully rolling out these services on each of the machines, reloading configs and restarting processes. The one thing we haven't discussed is process management. Now, typically on a Unix machine, you're going to be dealing with something that pretends to look like System5 init. Hopefully you're not dealing with a real System5 init, because that means you're on an excruciatingly old machine. But the problem with Go, if you've done any C or C++ programming, is that it doesn't let you do your typical dance of bind to a port, drop privileges, chroot yourself into a place, and double fork yourself to demonize. The most important part being you can't double fork yourself to demonize. The reason for this is probably the reason that you've been looking into Go in the first place. Because of its built-in parallel processing support, it has a thread scheduler that starts off as soon as your main function starts, which means that it has thread state. So if you fork, it doesn't play nice. The only thing that you can do is basically the equivalent of a POSIX spawn, which creates an entirely new process, does not have shared memory across them, unless you're doing file handlers or that sort of thing, but no actual native in-memory shared memory. And that means that you can't double fork yourself. So if you want to run system processes, which presumably you do, you're going to have to, and I mean have to, use a process manager like systemd upstart SMF if you're on Solaris, or run it. There is a bug open for this. I don't expect it to get solved anytime soon. It's a very hard problem. But I strongly encourage any of you to look into fixing that. So you've dropped your binary onto your server, you've dropped some config files, you've coordinated your machines so that way you can do graceful rollouts.
Sorry, I have a question. I mean, what is the actual impact or the downside of using Upstart or one of those other system managers? I'm not sure why you wouldn't want to use this.
Yeah, why would anybody want to demonize in this day and age?
It sounds like a problem with
I just have had so many people want to do this. I don't know why. I really don't. I mean, it's nice to know why and how.
At this day and age, you just tell them, yeah, there's a better way to do it now.
Yes.
Take a look at Run.
Yes.
I've did once where I had a client and I wanted it to automatically start a long-running daemon, if it hadn't already started. And I ended up having to shell to start and stop the daemon. But it's a very small edge case.
And in a case like that, I would suggest you look into the way that Opscode delivers their Chef's server product. It ships with a sort of jailed version of Runit that runs an Erlang daemon, an Nginx daemon, Ruby web service, Solar process, and a RabbitMQ service. And it basically has a wrapper script that lets you manage the state of all of those dependent services without having to write daemonization code for Erlang and Ruby and all of that stuff. So that is what I would suggest you look into if you've got that particular problem. Okay, so you've got your code on the server. You've presumably via SCP or something like that. You've upgraded it in place. You respond to signals so you can gracefully restart. But you've probably got something going wrong. Maybe you've got some crashing or incorrect results. Maybe you've got deadlocks or odd pauses, or you've got some performance issues, or maybe you've got the best kind of problems that are just great to have, like too many customers or too much data, and you've got to scale to meet that kind of capacity. So how do you do that? Well, I know it's probably not the most professional sounding thing, but everybody's going to just use func.printf anyway, so we may as well admit it. But when you're doing that, you're probably going to want a pretty printer, because coming out of the standard library, you don't get the best way of introspecting into data types. GoSpew is excellent for it, and if you're going to use a pretty printer, it's saved my bacon a couple of times. But I would appreciate if you guys would investigate doing proper logging, because you're going to rip out those printf functions eventually, unless you're doing like 12-factor standard out based logging. And to do that kind of logging, you can use the built-in log library that has an exciting function. I don't know if you've played with it, but log.fatalf. Normally you'd think that just says, I had a fatal error, here was the message. It does a bit more though. It will literally exit your function, your process. And I had one of my senior engineers get really freaked out the first time he realized that's what that did. Now, we use syslog at Simply Measured though, so I would encourage you to investigate that as well, because they have different APIs. They're not API compatible. They're pretty simple, though. They just take a string. So this log.error will send an error level message with the string that is passed in there. So I use a sprintf to format my error message into there. So those two are functionally equivalent. But if you're at Google or you care about the Google way of doing things, Google also has a C++ logging library called glog, and Rob Pike has ported something very similar to it to Go, and it's available at golang/glog. And it allows you to set an environment variable called v, which will let you dynamically tune how much logging is coming out of your process. It's also an excellent piece of code to investigate if you have resources that multiple channels are going to be interacting with. It builds a queue. It has mutexes around it. It's an excellent example of really safe multi-process code in Go.
I have a question about logging.
Yeah.
As a sysadmin, what do you prefer? Like, I've usually just write a file or write a standard out, but I've always felt syslog seems like the right thing to do. What would you or wish you'll go back into and do?
The thing about the syslog package is it doesn't use the standard library syslog facility, syslog 3. It uses the syslog protocol on UDP or TCP. And previously, I was opposed to that. I thought, it's in the standard library, it's in POSIX. Everybody should have syslog 3, just use syslog 3. Because of a long-standing bug in Nginx where they freak out because there's a chance that your syslog daemon could block and thus block your process when you call syslog 3 because it's a blocking call, I no longer hold that position. I now am of the opinion that using UDP or TCP and handling that blocking operation yourself is best, but I do really like syslog, preferably with the TCP windows instead of the new line separated messages, because it lets you do binary or UTF-8 data. And if you can, TLS is good too. All of that stuff is supported out of the box with rsyslog and syslog-ng. Those things are rock solid implementations, and I strongly encourage you to use them. We use syslog to the local machine for all of our applications, and then we use a syslog forwarder in our syslog to forward to a queuing box, which backs stuff up into a nice persistent queue, and then we have a bunch of Logstash indexers that pull it off, process it, and stick it in an Elasticsearch cluster. We also have another appender that creates flat files just in case we need a backup. We ship those things to S3 just until our data retention policy says we need to expire them, just so we've got all of that data. I love this setup. The only problem I've got is there's some issues with how Elasticsearch talks to Logstash, but honestly, that's not in the scope of your question. I find that syslog, the protocol, is excellent for shipping logs.
And does it, you send all your logs or just like critical errors, or the app only logs to syslog?
All the logs except for one process who has... So we have a cluster that manages all our writes to a Hadoop cluster, and those are small messages, and it gets a lot of them. We would need a multiple terabyte cluster and to screw our log retention time in order to take those logs. So those get flat files and go to someplace else. But otherwise, everything else does. Yeah,
generally, anything that you need to reproduce a user's problem should be one. Except for like really low-level debug information.
And you'd want that to go to syslog or that?
Let's go to something.
Right, yeah.
Yes.
Okay.
So the most important thing is find whoever gets woken up at 2 in the morning when a box goes down and ask them what they like. Because they'll build awesome tooling for you around it, and that's the most important thing. But there are 3 main kinds of logs that you should be doing. The first and most important is any business-affecting operation that your service provides, because presumably you get paid to do a thing, anytime that thing happens, there should be a log, an access log kind of thing, especially for destructive or changing operations. Then there should be exception or error handling logs. Those should have enough state information to say who called you when this error went down, who you were talking to when this error happened, and thread context, that kind of thing. And finally, debug logs, just because some days you really need it.
So, I mean, from my perspective, we want to use this log just because our systems will know how to handle that. That's a solved problem for them. They know where to put it. They know what pipeline to build. If we do our own logging, which we've done a lot of, no one knows where the hell it is, or how to handle it, or how to read it. So use the standard interface.
Yep.
And syslog's configurable. The system will go, well, I don't want the debug. I want this and this, and I want it here. And then that's on their side.
Well, by the way, I can and have given talks on just about every slide in this deck. So if at some point you'd like me to talk about logging in depth, I can totally do that. There's just a couple more things in this that I'd like to talk about. The next thing, once you've got logging, which everybody knows how to use, is metrics. And those tend to be a bit more complicated. People tend to not quite know what they need to measure, and they either measure everything that they don't care about, or they measure nothing, and even though they find out that they needed to measure it, they don't add that metric later. So that takes experience, and I can't teach that to you. But there are two really good approaches to doing this. So expvar is a package that comes in the standard library. Out of the box, it comes with two plugins. One, which you will certainly want, is the memstats plugin. It tells you things like heap usage, slabs, stacks, all the stuff you want to know about how Go is internally dealing with memory. Memstats will tell you through the expvar package, and also it will tell you all of the command line flags that have been passed to your function, to your process through an HTTP interface. I never understood the reason that it had that second one until I found out that Google does all their configuration through command line flags. It seemed like a hello world example, and in many ways it is an excellent one. So if you want to have a pullable sort of JSON API to internal stats, expvar is excellent for that, and it's in the standard library. But if you prefer to have more real-time metrics, and I encourage you to do that, say if you're using statsd or graphite or something that can store a whole lot of data, then you want to use something inspired by Coda Hale's metrics library from Java. So rcrowley has a library called GoMetrics. There's a couple of other implementations that are relatively similar, but the point is, it's got some statistics implementations to let you do that do the histogramming for you, that do the bucketing for you, that will do rolling averages for you, because that's math is solved and done, and you don't want to have to do it. Collects that stuff in a separate thread, so it doesn't affect your thing. And also, this one is nice because it's got a great number of outputs. It will talk to Graphite or statsd. I think it's got a Librato metrics output also if you want to pay somebody to host your metrics. That's great for push-style metrics. Now, most of the time I find that logging and manually built metrics will get me far enough. But the author of Heka has told me that he absolutely loves this profiler, the PerfTools profiler. And it works very simply to add it to your program. You just stick the pprof start CPU profile in your in your process, usually at the top of a main function or in your option handlers. You don't want to have this on all the time, but stick a command line flag or something so you can turn this on, and then it will dump out a profile data, and you can run pprof on it and get a lovely call diagram of how often these things are happening. And he said that he has used that for production usages of Hekad at what was it on that? And then debugging. So I hate debugging. I never like using debuggers. I try and avoid them as much as possible. I would rather strace and TCP dump and LSOF my way out of a problem always than to pull out a debugger. But if you need it, there's no better hammer than GDB. And GDB 7, not the older version that comes shipping with Mac OS X, will do it for you. All you need to do is install, is to grab this particular Python plugin, and it will allow you to inspect all of the makeable objects like slices and maps in Go. So I'm here because I'm an ops guy, and I don't actually care what the language is most of the time, but I've noticed that in the last couple of years, a lot of stuff has been coming out in Go, written by ops guys for operations people, and it tends to be well built and reasonably easy to run in production. These in particular, Heka is from Mozilla, Lumberjack is from the Logstash people, NSQ is from Bitly, Packer, I don't know if you've used Vagrant, but it's a Vagrant image builder. Surf down at the bottom is also from those guys. Docker is from the .cloud group for doing virtual machine images, sort of. And Doozer and etcd are sort of descended from the Chubby and Zookeeper approach to consistent configuration stores. All of these things are written in Go. All of these I would love to have a reason to run in production, and some of them I do. But if you're going to run stuff in production, it's important that you understand all of the stuff that we've talked about today. Because at 2 in the morning, trying to figure out how to restart your process or what thing is suddenly going slow is terrible. So now there's a few things that I've mentioned that are just suck. The dependency stuff in GoGet, I think it's broken at the moment. That it shouldn't be that way. And you know, you should be able to demonize yourself. It seems reasonable. But all of the boring stuff like syslog just works. And the important thing that I want to convey is all of your things have to interact with each other. And a lot of the stuff I showed today was boring old tech that it's really easy to interact with. And that's often what you want, because you're going to have to live with it for a long time. And it's going to have to live with other things, especially it's Go. It's probably replacing an existing system, right? Is anyone running Go in production? Did anyone start writing that thing in Go in the first place?
Yep.
Interesting.
We're working on getting a brand new API over the next month or so.
Well, I'd love, anyone who's running it in production, I'd love to have you talk my ear off about what you agree with, disagree with afterwards. But I want to thank a lot of the maintainers of that software I've been mentioning, because I've interviewed them and talked to them about how they do stuff, and I wouldn't be able to talk as competently, or at least sound as full of myself as I am, weren't for them. So to finish up, I'm Joseph Holsten. I'm from Simply Measured. Is anyone in here at a company that's not hiring? Okay, well, same here. And I want to thank you guys for having me here. Any questions?
Not a question, just to share that you were talking about demonizing and forks and threads don't mix. And I was kind of looking that up, and it seems the Stack Overflow answer is Supervisor D. So
Supervisor D is a Python process manager, and it's excellent as well.
it's running it in production.
Yeah, it's great.
Did you consider TOML as to store configuration?
The last time I gave this talk, it was on there.
Okay.
Totally, yes.
I just want to add a couple of comments about profiling in Go.
Yeah.
If you try it, it doesn't work on OS 10 because of a long-standing bug in the OS 10 kernel. And Russ Cox from the Go team actually wrote a binary kernel patch that you can apply to your OS 10 machine. And he's got a really great blog post about how he figured out what to do for this binary kernel patch. It's pretty awesome. But yeah, you need that patch if you want to profile in OS 10. Otherwise, your results are going to be all screwed. So that's one thing.
Russ Cox is crazy.
You're running your Xserve cluster.
And so then the other thing is for running in production, if you want to do profiling, there's another profiling package in the standard library, net HTTP pprof. And what that does is it adds an endpoint to a HTTP server in your application. And with that pprof command line tool, you can point it at that endpoint, and it'll start the profiler right there, run it for 30 seconds, and then give you the same output as you would have by manually starting it. So you don't have to add any fancy instrumentation or anything to your code. Basically, you just import this package, and as long as you're starting the default serve mux from HTTP somewhere in your app, then that endpoint will be available to the profiling tool. And I found that's by far for production apps the best way to add like CPU and memory profiling.
Just a little annoying because it magically sticks /debug, so hopefully you weren't using that now.
Yeah, so if my app is a web server, what I do is I spin up a separate serve mux for the actual app and then run the default one as kind of like another port for the profiler to hit.
That makes a lot of sense. Vince, here.
Yeah, sorry, there was a lot of talk about daemonizing. The reason why people did it before is so you could drop privileges. So, if like web server running on port 80, you have to start as root, and now you want to stop running as root, but the only way to do that before was to fork copy yourself that's running as whoever, and then exit that out.
So that means, so for that Go test, so I have some concern about test coverage, that number, and also Go has a benchmark test. So when you change anything, probably we can add a constraint there. So if your test coverage is lower than 80%, you failed. You cannot push that one up to production. And also benchmark, if you change something that one became slower, probably you cannot push that one to production. So that
I would like some of those things.
Production push process.
Have you implemented that?
Yeah, we did that one.
Okay. I would love to. So we are using Jenkins for our build server, and I would love to have those kind of guards in there. I'd love to talk with you later about that.
Yeah, we use Jenkins, but that one is Solar plugin, but for other language. But for Go, we just released that one 1.2. We have the Go test coverage tool and get that number very easily.
Okay, cool.
Just so you're using Jenkins, is that like how is your deployment pipeline like? Is it when you push code, is it build? Have you gotten there yet? We haven't. We're trying to figure it out.
So depends on the team. Depends on the team a lot. For our Ruby teams, which are the oldest stuff, we use Capistrano deploys. I don't touch that stuff at all. I just build out the scaffolding, make sure they've got the right users, and an upstart script, and they manage it. For our Java processes, we have an artifact server that Jenkins publishes to. We have a Chef cookbook that will drop the code on the server, but doesn't restart the process, doesn't do a graceful restart or anything, so it still requires a manual upgrade. So that's kind of like continuous. I mean, it's continuous delivery. It's just to the server, not to the user.
Sure.
And with Go, at the moment, we're using S3 as a bucket. We don't have a dynamic way of upgrading the pointer to the newest release yet. So at the moment, that's just a config attribute in a cookbook. But at that point, it's just a JSON bump. So I'm planning on writing a dashboard around incrementing that automatically in the next 6 months.
Sure.
I mean, once it's at the top of the priority list. Any other questions?
Are you running this all on Amazon?
Nothing in almost nothing in Amazon. Only our backup stuff is on Amazon. We have dedicated and we have Rackspace Cloud. Any other questions? Yo.
So yeah, how do you handle dropping privileges then? System, I haven't used Upstart much yet, but does that handle that or?
Upstart does, yeah.
Pardon?
Yeah.
Upstart does. You can say which user you want it to run as.
Okay, but like if you need to provision like a high level port like 53 or something, and then after that drop it.
Right.
Don't.
Good question, yeah.
So in that case, I would proxy.
Okay.
As
So that's
all-
Linux. Yeah, you can also like set cap your binary to
Yeah.
allow it to open
Yeah.
up lower level ports.
Yeah. You can also use systemd. Systemd's got a lot of really neat features. I personally think it's a monolithic monstrosity, but if you're into that, like with Upstart, then you may as well go whole hog, and it's great for the monolithic monstrosity that it is. It's way better than like LaunchD or Upstart, in my personal opinion. But yeah, that's got that built in. Basically, it's running as privileged. It will bind the socket for you and provide it to you as a file descriptor, or something like that. And so, yeah, so systemd, it's on Fedora. You can get it on most anything else. But yeah, if you're interested in process management, that guy's written lots of blog posts and
Oh, the systemd guy?
yeah, lots of there's a like 13.
No, it's like 20 parts now.
20. Okay, yeah, it's huge and it's great. But if you care about that kind of stuff and why on earth you would rewrite in it, which I mean, God bless him. But if I totally get you, but I'm mostly just trying not to restart my laptop in the first place. Besides, I mean, I ran Plan 9, and I've just given up for actually moving into the future. I just stuck in 1969, and that's fine.
Awesome, thanks.
Okay. I really appreciate it.
All right, thank you so much.